So section 2.3 is on solving equations. Two main types, linear and quadratic, but we're going to focus on doing it algebraically. All right, so if you're still a little rusty on like how to get x by itself in an equation, that's kind of what we're going to look at right now. So remember what an equation is. Equation is just when you put an equal sign between two expressions. There's an expression. 8 times x. There's an expression. The number 40. Put an equal sign between them. Now you have an equation. If your equation uses the variable x, like I did in mine, you can say that this, that is an equation in x. That just means it's an equation that uses the letter x. In a word problem, if they said to you, write an equation in y for something, that just means write an equation and use y as the letter. So, main thing we're going to be doing with equations today is solving them. Solve means to find the value of x that makes it true. So with the equation I wrote earlier, you divide each side by 8, and you get an answer of 5. 5 is the solution to that equation. Any question on what it means to solve? For an equation like this, there's only one answer. When we talk about quadratic equations, we can get up to 2 answers. And that's the highest we're going to look at today, quadratics, exponent of 2. Now, sometimes when you go to solve an equation, you realize that something special happens. Here's an example. So let's say this was a problem that I gave, in algebra 1. It's the kind of equation you would see. If I do out what's on the left-hand side, okay, with the distributive property, can anyone tell me what I would get? Yeah? This side would turn into 2x plus 6. And Alex, what if I did out the right-hand side? It would be 2x plus 6. And then normally the next step when you're solving an equation is to get all the variables on the same side. Well, if you put all the x's onto one side, what's going to end up happening is you're going to end up with 6 equals 6. That's the special case. Whenever all the variables disappear, and all you're left with is numbers, it's special. This is an example of an identity. An identity means you ended up with the same number on the left and on the right. Same thing would happen here. 3x plus 2 equals, it would be 3 minus 1 is 2. Subtract 3x from both sides, and you have 2 equals 2. 2 equals 2 is an identity, and an identity is true all the time. Any number that you pick for x will work. Every number. 6. That's the answer to this problem. 7. I get a B. Pop. Okay? Those are all answers to that question. Any question on that idea? So an identity, that's just a special type of equation. Now, you compare that to a conditional equation. That's an equation that is only true for certain values, not every value. This one is only true when x is 5. Okay, that's called a conditional equation. You can think of it as there's a condition to make it true. The condition is you have to let x equal 5. If you let x equal anything besides 5, it's not true. Any question on that? Yes.
So is it just a certain number, or is it just 5?
Well, for this particular equation, the answer is 5. But it could be any. But in general, when you're solving a linear equation, it has one answer. Yeah. So, how do we check if something is a solution? Like, if you think about this last problem, I told you that 5 was a solution. How could you check it? Well, to check it, take the number that you think is the solution and plug it back in. So if I thought 5 was a solution, and I wanted to check it, I would say 2 times what I think the answer is, I think it's 5, equals, and I put a question mark there because this is what we don't know, hoping it equals. We're going to find out. 2 times 5 equals 10. And then I do it out. 2 times 5, that is 10. I had 10 on the other side, so that checks. So x equals 5 is correct. Now, if you plug it back in and you get something like 10 equals 6, well, then that means what you plugged back in is wrong. Okay? When you check it, you're supposed to end up with the same number on both sides. What number you end up with, well, that depends on the problem, but it should be the same. All right, so let's look at this one. Now, what kind of equation is that? The highest exponent is a 3. I think we mentioned it yesterday, yeah? It's cubic. Well, that's not an equation we're talking about today when we solve it. So, I wouldn't make you solve something like that. What I might make you do, though, is check that -2 is a solution. I'm not saying it's the only solution. I have no idea. I just want to know, is -2 a solution? All right. So, Kiana, how do I check if that's a solution? Yep. And what number do we think is the solution this time? -2. And where do you plug it in? For x, which one? Which one? Yeah, both. You've got to fill it in everywhere that you have an x. So -2 cubed. When I substitute in, I usually put it in parentheses. And if you did it on the calculator, that's how you'd have to do it as well. So -2 cubed minus -2 plus 6. And if everything works, hopefully, we end up with 0. All right, Austin, what's -2 cubed?
8. Or is it -8?
It's one of those.
-8.
Negative, right? It's a negative times a negative times a negative. Gives me a negative. And Curtis, what's going to happen here? Minus 2.
It's going to become a +2.
It's going to become a +2. All right, so I got that. Tell me, what's -8 plus 2.
-6.
-6. And at this point, I think we can tell what's going to happen. -6 plus 6 is 0. So is -2 a solution? Yeah. Is it the only solution? Well, I don't know. But I know -2 is a solution. Okay. Any questions on what it means to verify that a number is a solution? Okay. All right. So I want to explain what this means because you see this notation a lot. It looks a little complicated. It really doesn't mean anything that fancy. This is the pattern that you will see if you have a linear equation. What I'm saying next to it is that A and B are real numbers. What does that mean? A and B are real numbers. They can be positives, negatives, 0, fractions, decimals. Basically, A and B can be anything you want, except there's one thing you are not allowed to let A equal, and that's 0. Because if you make A 0, what's 0 times x? 0. So what you've effectively done now is you just wiped that whole thing out. That's no longer called a linear equation. This is called a constant equation. It's just a number. So to be a linear equation, it has to fit this pattern. A and B can be anything you want. A and B can be any real number. That's what the capital R stands for. Except A cannot be 0. So let's start to solve this. And let's see if it fits this pattern. It might not look like a linear equation. When you look at it, you say, well, that's got a lot more stuff in it than this one does up here. But if you can simplify it and distribute it and somehow turn it into that, then it is linear. So let's see. Okay, so Cameron, on the left-hand side, what property am I going to use? I'm actually going to have to use it twice. Yep. Can you tell me what I would distribute first?
So you do the 2 times 2x.
Yep.
And then 2 times -3.
Yep. So let's distribute the 2. Okay, so we got that. And what am I distributing for the next thing?
3 times x and 3 and 1.
Right. And it's a positive 3. If that was a negative in front of the 3, the negative would be distributed with it. But it's a positive, so we don't have to distribute a negative. Sam, what's positive 3 times x?
3x.
3x. And positive 3 times positive 1? 3. Okay, still doesn't look anything like this, but we're getting there. So how about 1? What could I do on the left?
You add,
Sorry, 1, yeah.
like terms?
Yep, we're going to combine like terms. Is there any like term I can combine with 4x? 3x? And what does that give me? 7x. Anything I can combine with -6? 3? What's -6 plus 3? Good. Okay. So starting to look a little bit more like the other one. In fact, if at this step, if you moved everything to the left side and got it equal to 0, it would look exactly like this. You'd have a number with x, a number, and 0 on the other side. Okay, so this is linear. Okay, how about, Jenna, what would be my next step?
Subtract 5x from 0.
Yep, so we could minus 5x. That's gone. And if we want, we could add 3 at the same time. So we can do 2 things in one step. That's good. Yes.
Isn't that a positive 2 on the right side? Or negative 2?
Yes, thank you. Luckily it didn't mess us up yet, but it would have right now. So yes, positive 2. Okay, Ryan, what do I have on the left now?
Yep, 2x
2x.
equals 5.
And on the right, 5. Divide each side by 2. And there's your answer. X equals 5 halves. Any question on the algebra to get 5 halves? Okay, so that's solving a linear equation. Not an equation I would start out with in Algebra 1, because it's got a lot of steps to it. But at this point, hopefully you're pretty comfortable with those steps. All right, another type of problem that involves just solving something that looks like a linear equation is an absolute value problem. When we're solving an absolute value equation, it's going to look something like this. We always want to make sure when we go to solve an absolute value problem that this is by itself on one side. You want the absolute value isolated. That's perfect. Okay. Here's an example of it not isolated. Well, now you have the absolute value on the left side, and you have something else outside the bars. You have a +4 with that. I wouldn't want this +4 here. First thing I would have to do is -4 on both sides to put it on the other side. Most of the problems we do are going to look just like that. So we want the absolute value all by itself. Once it's by itself, we can split it into 2 problems. What number, you don't have to tell me the value for x, but just tell me what could go inside those bars, and the answer would come out to 3. What number could I put inside here? Yep?
3 and 3.
3 or -3. So we're going to split this up into 2 problems. One of them would be the same problem, just take away the bars. Either what's inside there can come out to 3, or as Tony said, it could come out to -3. Either way, if it came out to 3 inside the bars, or -3, when you take the absolute value, it would still be 3. So the first equation is the same as the original. Just take the bars off. X + 2 = 3. The second equation is the same as the original. Take the bars off and change the number on the other side to a negative. So the other one would be x plus, bless you, x + 2 = -3. That would be the other one. So when you solve an absolute value problem, you end up with 2 relatively simple problems to solve. I'm not actually going to do that one. That was just an example. I'll do this one. 2x + 3 = 5. Okay, so first thing, make sure that the absolute value expression is isolated on one side. Lucas, is my absolute value by itself on one side?
Yes.
Yes. There's no plus a number outside it. There's no like times a number like that. It's already by itself. So once it's by itself, split it. Split it up into two problems. Abigail, can you tell me the first equation that I would split that into? I want to split this into two equations, and I'm looking for the first one. Anything else? So right now, we don't have an equation yet. We need to turn this into something we can solve x. Equals 5. So there's your first equation. And how about the second one, Sky? 2x plus 3 equals negative 5. And those equations are very similar, so when you solve them exactly the same way. Minus 3 and divide by 2. That's how you're going to solve both of them. So in the first one, x equals 1. 2 times 1 is 2. 2 plus 3 is 3. And the second one, negative 4. 2 times negative 4 is negative 8. Plus 3 is negative 3. So when you solve an absolute value problem, you're going to get two different answers. And you just want to make sure you write both. Any question on that idea of splitting it into two problems? Okay. So the last thing we'll look at before we finish up with quadratics is another application of a linear type of problem, not a quadratic yet, and it's called a mixture problem. So when we want to solve a mixture problem, we're going to have to write two equations. And the way a mixture problem works is they're going to tell you you're starting with two solutions. Maybe you have like a 50% solution of, I don't know, rubbing alcohol, and you've got a 70% solution. And what I want you to do is take the two and mix them together. And I want you to end up with maybe, well, you got a 50 and you got a 70. I want you to get something in the middle. I need a 62% solution. And I want to have exactly 10 gallons in it. So what I want to know is how much of each solution would you mix together to make it 62% rubbing alcohol, and so I end up with 10 gallons. So the first equation you set up, that's the easy one. Let's say that you use x liters for your first solution and y liters for your second one. You would do x plus y equals however much they want you to have, like 10. So the first equation you set up is for the amount. And the second equation you set up is 3 pairs. And each pair is concentration times amount. And just to be clear on that, that's the concentration percent as a decimal. I'm not going to write that every time, but that's what concentration is. So 12% would be 0.12. So you're going to have a concentration times how much you use from your first solution, plus a concentration times how much you use of your second solution. That's the left side. And the right side, this is going to be given to you in the problem. This is the final concentration. What do they want you to mix the two together to make? 70%, 30%, 12%, what do they want you to make? That's the final concentration. And the total is how many gallons or liters or whatever that they want you to make. So you're always going to know these two numbers on the right. The only thing you're not going to know is amount 1 and amount 2. Everything else there will be a number. Okay, so let's try a mixture problem, and then that will finish up solving linear equations. All right, so we have two solutions we're going to mix together, a 10% and a 25%. If you mix them just right, you could get anything between 10 and 25. I want to mix them together so that I get 15 liters when I'm done. Okay, and you might say, well, that's easy. Just do 7 of this one and 8 of this one. Well, that's one way to get 15. But they also want me to get exactly 12%. So just kind of using common sense, which solution do you think I'm going to use more of? A or B? You're going to mix them together, and you want to end up with 12%. Yeah?
A.
Yeah, you're going to use more of A, because the final concentration you want is just a little bit stronger than A. So you're going to use mostly A. You're just going to pour in a little B, and that's going to bring it up to 12%. So let's write an equation to figure out how much of each solution that we use. I think the easiest thing to do is let those two letters be your amounts. And you have to pick two variables. I would let A be the amount of the 10% solution and B the 25%. So I'm going to use those as my two letters. How would I write this first equation?
You just do 10 plus 1.
So how much of the 10% solution are we using?
All of it. Right?
Well, a certain amount of it, maybe 6 liters, 7 liters, I don't know yet. But we have a variable that represents how much. What's our variable that represents how much we're going to use of the 10%? Scott? A. So the amount, AMT stands for amount. The amount that we're using of the 10% solution is A. What's the amount of the 25% solution? B. So how would we write this equation with those two amounts? Yep.
10A plus 20B.
So what is amount 1? How much? Like how many liters are we going to use? I'm losing people. You're thinking too much. A is the amount of the 10% solution. You're going to use A liters. B is the amount of the 25% solution. So amount 1 is A. Amount 2 is B. So when you mix together A and B, by adding them up, you're going to take this many liters of solution 1, this many liters of solution 2, and when you add them together, you want a total of how much? 15. That's it. That's your first equation. The first equation has nothing to do with the concentrations. It's an amount plus an amount equals a total. the concentration with the 0.1 or whatever we're going to use, that comes in the second equation. So the second equation is going to look something like this. It's a concentration times an amount plus concentration times amount equals concentration times amount. And we go through each solution. So what's our concentration for the first solution? 10%. And how about if you write that like that? Yeah? 0.1. Yeah. 0.1 times how much are we using of that solution? What's our variable that represents the 10% solution? A. Next one. What's our concentration of the second solution? What is it? And as a decimal? 0.25. Concentration, amount, concentration, amount. What's the amount we're using of the 25% solution? B. Now on the right side, it's the final concentration times the final amount. What's the final concentration they want me to get here? Yep.
12.
12, and how would you write that?
0.12.
Yep, 0.12. That's the final concentration. And the final amount that they want me to get is
15 meters.
15 liters. All right, so on that right-hand side, we can multiply 15 and 0.12. So let's do that, make that a little simpler. And we can shorten this. That's just 0.1a. This is 0.25b equals, and I need to do 0.12 times 15. What's 0.12 times 15? Yeah, done it. 1.8? Okay. All right, so here is the simplified version of that equation. And here is my other equation. We have two equations, and they each have two letters. Anyone remember what you have to do with this top one? And then whatever you do there, you end up filling it into the bottom. What is it? Anyone remember? Substitution. Yep. So we have to substitute. To substitute, you have to have a variable already by itself in one of the equations. I think the top one is the easiest one to get a variable by itself, because the bottom one has decimals. So if we got a by itself in the top one, can somebody tell me what a would equal? Yeah. You could write negative b plus 15. You could say 15 minus b. Exactly the same thing. So that's what you get if you get a by itself. Now, what do we do with that 15 minus b? Yeah. Plug it into a. Right there. And that will give us our answer. So everything else is going to stay the same. 0.1, leave a little bit of space. 0.25b equals 1.8. But we're not going to write a. We're going to write 15 minus b. And that's a decimal. Now, if you look at that equation, there's only one type of letter. It's just a B. Before we had two types of letters, A's and B's. That was a problem. Okay, so we had to use substitution to get rid of one of the letters. Okay, what's 0.1 times 15? Yep. 1.5. 0.1 times negative b is just negative 0.1b. And we'll just copy the rest. Okay. Any like terms on the left-hand side? Naija?
0.1b and 0.25b.
The 0.25b and what other one?
Negative 0.1.
Negative 0.1. What do you get if you combine those two together? Think of it as like 0.25 minus 0.1. 0.15? Positive 0.15b equals 1.8. What would I do next there? Oh, Tyler? Yep, you move the 1.5. How would you move it? Yep. Perfect. That's gone. And now we have 0.15b equals, and that's actually a nice number because of our next step. My last step is to divide by 0.15. And divide by 0.15. You can use a calculator if you need to. But does anybody know what 0.3 divided by 0.15 is? How much? I think someone said it.
0.02.
Think of it as like 30 divided by 15. That'd be the same question. 2. So B is 2 liters. And we needed a total of 15. So then how much do we need for A? It has to be 13. And that's how a mixture problem works every time. The only thing that's different is the percentages. That's the general pattern for a mixture. Any questions, or does anybody need to copy down the two formulas? But the steps are exactly the same in every single problem. So like in tonight's homework, it might say you have a 30% and a 40%. So just change the two numbers and do the exact same thing again. Yeah. Yeah, you sign up. Okay, so that's linear equations. The last thing we're going to look at is quadratics, but we've already been looking at quadratics. We've already used quadratic formula. We've already done factoring. So I don't really think you're going to see much new in this last thing. So that's what a quadratic equation looks like. Okay? Ax squared plus bx plus c. Highest exponent, always a 2 for a quadratic. Now the a, the b, and the c can be any number you want, except a can't be what number? Because if it was this number, it would wipe out the x squared. Yeah?
0.
Right. A can't be 0. But other than a being 0, it can be anything else you want. So this says a, b, and c are real numbers. Positives, negatives, fractions, whatever you want. Except a is not 0. So what's one way to solve a quadratic that's not the formula? Like you do the two sets of parentheses. Remember, what's that method called? Yeah? Factoring. Okay, so factoring is one way to solve a quadratic if the numbers work out nice. And you had some in the homework last night that you had to factor. So this isn't intended to be like a full-blown review of factoring right now. That's like a whole 3-day thing in Algebra 1. So we'll go through a couple examples, but if you need more help with factoring, let me know. Now, because I just mentioned one way to solve a problem is with factoring, and then right below it I said solve, this is going to be doable with factoring. So, when you want to factor, what's the first thing you write down? And it doesn't even matter what the numbers are in the problem. You would do this for any problem that says factor. Yeah? Even before that. Even before you write any letters or numbers, you have to write something down first. Parentheses. How many sets? 2 sets. Highest exponent is a 2, you're writing 2 sets. Now, you figure out what times what gives you 2x squared. Anyone think they could tell me what would go at the beginning of each? Yep. Yep, 1x and? And what was the other one you said? Well, what would go right here? Well, if I did 1x times 1x, that would give me 1x squared. I want 2. Yep. So 2 is a little easier to work with because there's only one way to get a 2. 1 times 2. If this number was like a 12, well, good luck. Because now you have to do 1 times 12, 2 times 6, and 3 times 4. They all could work, but only one of them will. So 2 is a little easier to work with. So 2x and x. How about my signs here? Both positive, both negative, or one of each? And think about what times what would give you a negative number. Yep. A negative and well, a negative and a negative would multiply to give you a positive. It has to be a negative and a positive. And it does matter which one you put where. If you get it wrong, you're just going to have to switch it. So let's try, that would be my suggestion. I would try a negative and a positive. And now we need 2 things that multiply to give me negative 3. So what's 2 numbers that multiply to give me 3? Yep.
1 and 3.
Yep, 1 and 3. And I would do it exactly in the order that you said. Let's check it. 2x times x is 2x squared. 2x times 3 is 6x. Negative 1 times x is minus 1x. And 6 minus 1 is 5. Perfect. All right. Now, just write down the 2 answers like we did in last night's homework. Either that is 0, or that's 0. Jackson, what would make this first one 0?
The first one would be
1/2. 1/2. And what would make the second one 0? Sure. Negative 2. Good. Any questions on that? So that method works fine as long as it's factorable. If it's not factorable, then we can use a formula that we've already been using, and that's the quadratic form. Now, even if factoring does work, you could still use quadratic formula. You can use this all the time. This just isn't the fastest way to do it, but it will work. We did a lot with this part, b squared minus 4ac, past couple days. Now we're incorporating it into the entire formula. Let's see. So to use the quadratic formula, you have to be able to identify what's the a, what's the b, and what's the c. So the easiest way to do that is to make sure you put 0 on one side and you put everything else on the other. then that's A, that's B, and that's C. Okay, so we'll try an example where it's a quadratic we have to solve, but you can't factor it. And then that'll be the last one. Does everyone have the quadratic form? Let's see if we can solve that. Okay, so first question, is it set up the way that it should be to be able to identify the A, the B, and the C? Cameron?
Subtract the 1.
Yep. First thing we're going to do is subtract the 1. So we have 2x squared plus 2x minus 1. Okay. Now, what I like to do, you don't have to do this, it's up to you, but I like to write down A, B, and C off to the side. Okay, Austin, what's my A value in this case?
It would be 2x squared.
It's in there somewhere.
2.
Just the 2, yeah. So A is 2. How about my B value? What's my B value, right? 2. And my C value? Type?
1.
Negative 1. Now fill those numbers in to that formula and see what you get. Negative B. Plus or minus, I do a couple things as I go. So I'm going to do the B squared right now. What's 2 squared? So that's 4 minus 4AC. 4 times 2 times negative 1. And what are we going to divide all of that by? (2a). And what's 2a in this case? 4. Yep. Now simplify that square root as much as you can, and you're done. So negative 2 plus or minus. We have minus, what's 4 times 2 times negative 1?
Negative 8.
Negative 8. So that's 4 minus negative 8 over 4. And that's going to turn into a plus. 4 plus 8 is going to give me 12. And the last step is to simplify that square root of 12 as much as you can. Does anybody remember what that simplifies to?
Could I have your attention, please?
All right, so we're at the very last step. So everything is good there except the square root of 12. Okay? It's not that we did anything wrong, it's just 12 can be simplified. Can anybody think of 2 numbers that multiply to give you 12? And one of them you can take the square root of. Yeah?
3 and 4.
3 and 4. So when you write the square root of 12, we should write it as square root of 4 times square root of 3, because 4 times 3 is 12. But then the square root of 4 gives you 2, because you always should simplify a square root. So then we get that. And what is every one of those numbers divisible by now? 2. Just happens they're all divisible by 2. That doesn't always work out that way, but this one did. How many times does 2 go into 2? Once. 2 into 2. And 2 into 4. 2. Yeah, that doesn't always happen. So the final answer ends up being negative 1. Plus or minus, you don't need to put 1 square root of 3. You can just put square root of 3. Over 2. And that was the last. Okay, so homework, I did tweak it a little bit and just changed a couple questions. So be sure if you copy it down, be careful, just write the right numbers.
Could you go back to the homework and get it all down?
Back up right here.
No, yeah, just where it says the homework.
Oh, yeah, I'm gonna put that up right now.
Oh, okay.
Yep. Okay, so page 96, that is the homework. A little different from the video that's from last year. But we'll take a look at that first thing tomorrow.